Hey kids, here are some examples that we're going to go through in class if you're in person, and remote you can go through it on your own. So just a couple of reminders. Delta x is your final minus your initial position, and that is your displacement. Your average speed, remember, is going to be your distance over time. And your average velocity, remember, is your vector. And that's going to be your displacement over time. Okay, so let's get started here. Here's a good example. It says, ignoring the curves, find the distance and displacement when moving from A to B. Well, you can pretend that it's just a rectangle, since it's said to ignore the curves. And if you're going from this position, you're going to come down here, go across this whole length, and right here. So your distance would be the total path traveled, so you would just add up these parts. This here is 100 meters, and you get halfway through this, so you get 15 meters here and 15 meters here. So if you just add up all of those things, you would get 15 plus 100 plus 15 gives you a total of 130 meters. Now, the actual distance, if you were to take it from here and just do a straight line vector displacement, your delta x would then just be 100 meters, because they don't care about the fact that you went down, across, and up. They just care about your shortest distance from A to B. Okay. Here we go. We have a roller coaster. It moves on a certain section of its track with an average speed of 12 meters per second. So V average is 12 meters per second. How much distance is covered in 6 seconds? So we can just even use D for distance. And the time is 6 seconds. So start out with your equation. V average equals distance over time. Now you can either just solve right now for distance, or you could plug your numbers in. If we did 12 meters per second is D for distance over 6 seconds, we know we would multiply both sides by 6. So that means the distance covered would be 72 meters. Always remember your units. We'll jot them down real quick. Remember displacement and distance in units of length. Typically in meters, they could be kilometers, they could be inches, they could be feet. Anything that measures a length is going to be distance and displacement. Your speed and velocity, those will be in meters per second, or kilometers per hour, or miles per hour, or inches per second, but it is a length divided by a time. All right, let's keep going. Here we have two cars. They're driving parallel to one another. And tell me everything that you know about the motion of these two cars. Well, from the other PowerPoint, we know that you look at a few things with this. Your X versus T is telling where. And then think, what does the slope tells you? The slope tells you velocity, which tells you how fast, and something else very important, what direction. So remember, If it's a positive slope, that means we're moving to the right or we're moving up. And if it's a negative slope, it means you're moving backwards or to the left or moving down. All right, so this car, if we looked at trip A, it's moving along right here. If it's a straight diagonal line, that means it's constant velocity. Now it looks like it's picking up some speed, and now the slope is getting smaller and smaller. If you laid your pen or pencil across this line and you watched it, we would eventually get to this point where that slope is 0. And remember, what that means is that there's no motion, there's velocity 0. So that is a point right here of interest, because then what happens is now we have negative slope, right? And it starts off pretty small, and then it increases. So this whole half of this trip, he's moving right. But then here he's speeding up, then he's slowing down to the point where he gets to 0, then he turns around, he's going the opposite direction. Now he's going in the negative direction, and he's speeding up until he gets to about here where that's constant velocity in the negative direction. This guy, same motion the whole entire time. That just means he's moving at positive constant, or moving with positive constant velocity the whole entire time. There's something interesting that happens right here too. Right at this point, they're in the same location. So it just means that they pass one another. All right, here we go. We have a tennis player, and we're looking for average velocity for section A, 0 to 2 seconds, section B, 2 to 4 seconds, section C, 3 to 5 seconds. So think about your definition. Always start with that first. Your average velocity is going to be your change in position or change in displacement over change in time. So all you have to do is read those positions off of your graph, your final minus your initial, and then your time. So I'll do one for you, and then you should be able to do the next. You should anticipate looking at this. Is this going to be a positive or negative velocity? Hopefully you notice that it's a negative slope, so you know that it's going to be a negative velocity. So really all you need, your final position is 1, minus your initial is 3, and then your change in time is 2 minus 0. So you will get a -2 over 2, which is a -1 meter per second. It just means that she moves to the left 1 meter every second. Do the same with B, and you'll get a positive velocity here. Here you'll get a negative velocity. Now the last question asks you for the average velocity over the whole time from 0 to 5 seconds. So you do the same exact thing. Here is your final position. Here is your initial position. So starting off with your equation, and the more you write them, the more they will sink into your memory and be easier to use. So your final position here was 2. And then her initial position was 3. And then it goes from 5 to 0 seconds. So 2 minus 3 is -1 over 5 meters per second, which is a -0.2 meters per second. So just on average, throughout that whole trip, she's moving in the negative direction, and she's only covering 0.2 of a meter each second. All right, let's keep moving. The position of a ball as a function of time is given by this equation. Now again, you could write it that the final position is your initial position minus 2 meters per second t, which is fine. And remember, this came from our last video, and all we did was take what we know, the y equals mx plus b, and we applied our physics to it using an xt graph. And remember how we went from here to physics. We said, well, what's on our y-axis? We plot x on our y-axis, and then our slope of an xt graph, remember, is your velocity. What's on our x-axis? We get time. And then our y-intercept was going to be our initial position. And then we can just rewrite that a little bit more specifically, our final position. Then we just write this first, our initial position, plus the velocity and the time. So if you want to just find the position at any time, you just plug in this 2 into your t. So the final position will be the starting point. So they're starting 3 meters, and then they're moving to the left at 2 meters per second for 2 seconds. So what that means is that the final answer, if you just crank out that math, you're going to get 3 minus 4, so -1 meter. So it just means that you're going to be 1 meter behind some 0 point. So if you made out a number line, it looks something like this. Here's our 0. This is where you started. You're 3 meters ahead, and then you move to the left, and you end up here. Alright, so now we have 2 toy dogs, right? And they're moving in a straight line with the following equations. One has -4 plus 1 meter per second t, one has 8 meters plus -2 meters per second t, and we could ask all sorts of questions. Which direction of the car are the dogs moving? Well, you would look at this term for each of them. If it's positive, it means it's positive v, which means they're moving to the right. If this term is a negative, that means it's a negative velocity and they're moving to the left. So these dogs are actually moving towards each other. Which dog is faster? Well, you're going to look at the velocity term again. Whichever one has a bigger number is going to be moving faster. So obviously, even though he's moving to the left, he's still going faster than the dog that's moving to the right, because he's got -2 and he's got +1. Here's a little bonus thought. Can you figure out when they are at the same location? At what time does that happen? Well, what you would do is you would set these equations equal to each other, and solve for t. So I would say -4 meters plus 1 meter per second times t equals 8 meters plus -2 meters per second times t. And then solve for t. So I'll just run through the algebra real quick for you. We want to get all the t's on one side, and we're going to get all the numbers on the other. So let's add a 4 to this side and a 4 to this side. And this is a -2. So in order to get rid of it, we can add a 2t and add a 2t. So these two go away, these two go away, and we are left with 3t equals 12, and t equals 4 seconds. So 4 seconds after they start moving, they're going to be at the same spot. All right, I think this is our last one. Consider a child that is at x equals 8.1 meters at t equals 0. So that just means if we start a stopwatch, we're just going to start it, and this kid is 8.1 meters ahead of some origin that we chose. And they're moving with a constant velocity of negative 1.6 meters per second. Write the equation of motion. Now, this is what I suggest you do, right? What you know. And then remind yourself with a little sketch of an XT graph. All right, here we go. And you don't know. We'll leave that line off for a second. But this way you have it in your head, you write it down, and now you remember, oh yeah, you know what, in physics I put displacement, sorry about that, you put displacement on the y, and then I remember that my v is my slope, and then what's on my x-axis, that's a t, and then this is my initial position. All right, so here's my equation of motion, and this is what you'll just have to input if they ask for it in mastering. Remember, we usually put the initial position first, so I'll say positive 8.1 meters plus, what's my velocity? Here's my velocity, negative 1.6 meters per second, t. And that could tell you everything you need to know and where that kid will be at any moment in time. What does this tell you? It says he's moving to the left. This tells you they started 8.1 ahead of some origin place. And that's it. So you have a whole bunch of mastering physics. Now, there are a bunch of them, but some are just quick questions like, hey, what are units for this or what are units for that? So don't get freaked out when you first see it. And they are due by next Wednesday night. So that'll give everybody enough time to go through them, ask questions, reach out on Remind, or follow up on that, Remote Wednesday. But that's it. Have fun.